Alright guys, hi everyone. Hopefully you are enjoying your days off. So even though we are doing things online now, but we still have to keep going. So this is still Cheng. Sit down, shut up. Alright, so just let you guys know that I did upload the, the remaining of the lesson from Friday on the D2R show in my under my name Cheng's folder, which says video lessons or something like that. So check those out. That will wrap up the stuff from the last unit. Okay, so now we are moving on to the new unit, which is called Linear Inequalities. Make sure you still have your graphing calculator with you, because we will be just basically doing the same thing, like going over notes, do examples, using the graphing calculator to help us work out the problems, except now you're doing it at home or elsewhere. Anyway, so let's get started. So this one is called linear inequalities in two variables. Before I move on to do more stuff, just let you know that I have already posted a PDF version with all the answers. But if you want some more clarification, you are welcome to watch this video, and I would also suggest you to pause so that you can try the problems yourself first, or at least think about the problems yourself. Okay, so let's talk about this, how to graph a linear function. This is Math 10C stuff, so I'll just quickly show you the notes. Hope that will brush up your memory. So you might want to pause here, copy down the notes, or read through the notes here. So isolate the y, so the function is in slope-intercept format. Okay, so what is the slope-intercept format? If you look at that here, that's the formula sheet. This is the slope-intercept form, slope-intercept. And then you plot the y-intercept, the b value, and then use the slope to find the rest of the points, the m value. Okay, so your slope-intercept form is this. Y equals to mx plus b. Right? So a random example of this would be -3/2 of x plus 2, and the graph would look like this. Of course you can graph this on your graphing calculator, but I hope you can do this in your head. So what you need to do now is to substitute 0 for x. In that case, that will give you a y-intercept. So 0 times this gives you 0, 0 plus 2 gives you 2. So that means we have a point here. And if you do a few other points, you can actually have a pretty good line to look at. And of course the slope is negative, so that means your graph looks like this. Arrowhead. If it is a positive slope, it would be like this. Alright, so let's keep going. This is how you graph a linear function, a line. That's why we call that linear. So in math, when we say a point that satisfies the equation, that means you would actually find that point on the graph. In this case, if you have a point that satisfies the equation, it would be a point either here, 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 or here, something like that. Anything along the line. Alright, so let's work out a question here. You have 4x plus 2y equals to 10, and the question is this point 1 and 3 on the graph or satisfy the equation? Right, so what you need to do is plug in the value of 1 and 3. So your 1 would be x, your 3 would be y. So plug in 1 for x, 3 for y into this equation to see if the left hand side is equal to the right hand side. So you don't have to do anything. As we did this before, when we check for extraneous root, you want to make sure that the left hand side is equal to the right hand side. So let's do this. So 4x is 4 times 1 plus 2y, y is 3. On the left hand side, right hand side is still 10. There's nothing you can do, so let's work out the math. 4 times 1 gives you 4, plus 2 times 3 gives you 6. Right hand side is still 10. Left hand side, 4 plus 6 gives you 10, and right hand side is 10, and of course 10 is equal to 10, so that means it is legit. In this case, that means the point 1 and 3 is actually on the line, so we say that the point 1, 3 is on the line. That's one way you can say that, and if you want, you can elaborate that, because you can also say that in this case 1, 3 satisfy the equation. Okay, just like that. Okay, next. So a linear inequality is essentially a linear function in which the equal sign is replaced with one of the 4 inequalities. So of course linear and linear, except that in this case because we are talking about inequalities. So you see the inequality signs in the second, so therefore we do not have the equal sign. So there are 4 different types of inequality signs. So these are the 4 types. And if you look at the first one, I hope you learned this from junior high math or math 10C. Okay, so this one means less than. So that means ax plus by is less than c. Second inequality here is less than or equal to, less than or equal to, because as you can see we have the less than, but also this is the equal sign, so there are 2 things going on. Alright, so you can, for this one you can read that as ax plus by less than or equal to c. So it may be less than c, it may also be equal to c. The third scenario is this, that this means greater than. So that means you can read this as ax plus by is greater than c. Last but not the least, the fourth type. So if you look at this, I'm sure you are smart enough to figure that out. So this one is greater than or equal to. So just like the second one, you have one inequality sign here, and then here is the equal to part. Okay, so 1, 2, 3, 4. So when we graph an inequality, the set of points that will satisfy the inequality will be found in the solution region, either above or below the line. Again, the boundary line could either be a solid line or a dotted line, either way. Next, we shade the solution area above the boundary. Line if you see greater than or equal to, as long as something is larger than, one thing is larger than the other thing, we shade the above, like we shade the region above the boundary line because it is larger than. Okay, and the second part of the solution would be shading below the boundary line. Again, the boundary line would either be a solid line or a dotted line. In that case, when you see a less than or equal to sign, so anything is less than the other one, then you put your answer is below, or your solution is below. So a general graph would look like this. If you have a line here in a function, then anything above would be greater than or equal to, and then if there's anything here, then it would mean it is either less than or equal to. Okay, so let's graph this. Take out your graphing calculator. I know you may say that, Chang, we don't have this on your graphing calculator. Yes, we do. Alright, except that in this case we are not doing that. So basically, you need to plot this. You may say, how am I supposed to graph that? Well, my tip for you is treat the inequality sign as an equal sign. Think of this as equals. Okay, so do you know how to graph this? I'm sure you all do. So if you look at the graphing calculator, you have this. Alright, so let's graph this here. So for your graphing calculator, in order to put in this, we need to manipulate this first. So you need to graph the boundary line by isolating y. So first step, graph the boundary line by isolating y, because if you look at the graphing calculator, you only have y's here. Alright, so as I told you, Chang's technique here, think of this as an equal sign. So if you manipulate this, so 2x plus 3y equals to 6. Okay, then minus 2x on each side. So minus 2x, they cancel out. So that means 3y is 6 minus 2x, and then divide both sides by 3. So 3 and 3, they cancel out. So that means y is divide this by 3, you get 2, and then minus, divide this by 3, you get, in this case, a fraction, 2/3 of x. So if you want, you can rewrite that as y equals to negative 2/3 of x plus 2. In this case, why do we want to do it this way? Because in this case, you have the slope-intercept form. So having the slope-intercept form, that's handy, because hope you all still remember that. That means we have the y-intercept of 2. So when x is 0, y is 2. Alright, so we do need more points, so there are two options. First option is you set up a table of values, x and y, plug in different value of x, then you have different values of y. That's one way. Or if you can quickly plot this on your graphing calculator. Okay, so let's do it this way. So you have negative 2 divided by 3 x, and then plus 2, and of course we go to number 6. So our graph looks like this. If you want, you can look at the table of values and get more data points. Alright? Okay, so there should be one more point here. Now, this is your graph. However, don't forget that we arbitrarily change the notation, so it is not equal, it is actually less than or equal to. So change all this. And then replace them with less than or equal to, 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 like now that's half of the question. So the second thing we need to do is shade the solution area. Shade the solution area. Okay, so if you look at the question, look at the last part here, we know that y is less than. So when we say greater than or equal to, less than or equal to, greater than, less than, all these kind of inequalities, we always look at it with respect to y. So in this case, y is less than, so therefore this is what you would do. Anything this is above, this is below. Anything that is less than or equal to, that means below down here. Maybe I should erase this to make the line longer. Oops. Alright, so less than or equal to, so two things. First thing, because we have the equal component here, therefore our boundary line would be a solid line, of course. And then to indicate the solution area, because it is less than or equal to, so it is below the graph. Okay, greater than or equal to, above the graph, less than or equal to, below the graph. So anything here is an acceptable answer. This form, the slope-intercept form, help us to graph this, find the solution area. However, it might make more sense to look at this. It says 2x plus 3y is less than or equal to 6. So that means if you pick any point here with a particular x and y value, the sum would be less than 6. So let's go to part B here. Okay, part B, algebraically determine if the point -2 and 4 is a solution. So if you look at the graph we just plotted, -2 and 4, -1, -2, and then 4, 1, 2, 3, 4 would be a point here. So I'm lucky that this time I did my graph accurately, so I can eyeball that. So for you, when you plot the graph, make sure you also do it as accurately as possible. So if you look at this, algebraically determine if this point is a solution. So if you look at this, it is a graphical solution. This point is not part of the highlighted region, so that means it is not. However, we're asked to do this algebraically, so therefore this is not an acceptable answer. You cannot say this point is above the highlighted region or the shaded region. Alright, so what do we do then? Of course, algebraically. So this is my x value, this is my y value. So what do? We plug it back here. You can either do it like this or do it this way, but I would personally prefer to do it this way because I can compare that to a number. So 2x plus 3y less than or equal to 6. 2x plus 3y is less than or equal to 6. So plug in -2 for x and 4 for y. 2 times -2 plus 3 times y, which is 4. Right hand side, leave that as is. So left hand side here, 2 times -2 gives you -4 plus 3 times 4 gives you 12. Right hand side is still the same, there's nothing we can do. And then left hand side, -4 plus 12 gives you 8. And then right hand less than or equal to 6. And as you can see, obviously 8 is not less than or equal to 6. 8 is greater than that, so that means this is wrong. Okay, so let's summarize this here. So we say that therefore the point -2 and 4 does not satisfy not the solution, the inequality. Okay, if you want, well, we're done with the whole question. If you want, you can pick a point here. So let's pick this point here, 0 0. Okay, 0 for x, 0 for y. Plug that in here. 2 times 0 gives you 0, plus 3 times 0 gives you 0, 0 plus 0 gives you 0. So 0 is less than 6. Of course, that's the case. So makes sense. So any point here would satisfy the equation.